So as we analyze our mixed cost, we're going to look at the fact that what we're seeing here is that there is both a variable and a fixed component of mixed cost. So the idea is that we have got to be able to separate fixed and variable costs out of mixed cost, because when we look at the calculation in cost volume profit, there is no mixed cost. Our two choices are fixed and variable. So if you've seen this formula before, it may have been a little while, but this is really the slope, okay? So basically, within this formula that we're going to derive, we've got two ways to do it. We either have high-low or regression. We're basically using our total cost, which is represented by Y, and that takes into account how many units or activity we have times our variable cost per unit plus our fixed cost. And that's going to allow us to either one, separate a total cost item into variable and fixed, or we can actually make some forecast or some estimates about what those mixed costs might be. So we're going to work through an example here in just a minute, and it's in the Excel file that you can locate in Canvas right underneath the class overview. And so we're actually going to work through high-low. Okay, we're going to try to keep it pretty high level and focus on high-low. We're going to use two data points where we analyze the highest and the lowest total cost. Okay, we're going to compare that to its related highest and lowest activity to calculate a variable cost. And then from there, we're going to kind of separate out what those costs are. Now, the other one that I'll show you a quick glimpse of is called regression. And I want you to know the difference here between the two. Regression is just a way that we can use all data points in a given data set, okay? So for example, if we think about a chart here where I've got a graph and this represents my units of activity and this represents my total cost, okay? Now I know I'm going to have some costs somewhere along this line, okay? High-low says, oh, we're only using two data points of information. So whatever this is representing here versus what this is representing here, okay? Now, that doesn't give us a great model, but it gives us some sort of model, okay? So that's one way we can separate out these mixed costs. But the idea with regression is that it's going to use all of these data points, and I'm terrible at drawing graphs and charts here without real information. But imagine that we have all these various data points, okay? And the idea is that this best fit line would give us a better model than just two data points. Why? Because we could have 1,000 data points, we could have 600 data points, we could have 100,000 data points. And the idea is that that would give us a better model to follow, okay? So we're going to focus on that idea, okay? But we're just going to calculate high-low. So when we're looking at high-low, this is a snip that I just grabbed out of Excel. So if you are not in Excel yet, go ahead and pause the video and go grab that Excel file and download that. And hopefully at this point, everybody has access to free Excel through K-State. All right, so when we are looking at this, the first thing we want to do is, really build the model, okay, that we can use to make some estimates. But the idea is that if this represents our units of activity, this represents our total maintenance cost, how do we really know we're looking at a mixed cost? Well, remember, by definition, a variable cost per unit doesn't change. So these are all changing. So they are not variable costs. What do we know about fixed cost per unit? Well, they vary inversely with activities. So the more activity we have, the lower the per unit cost. But notice that that's not varying in direct proportion with any number, okay? They're kind of just all scattered all over the place. So how do we know they're mixed? Because they vary, okay? They're changing the cost mixed cost per unit is changing at some rate, which means there is a component of fixed cost plus the variable cost. So the model we're going to use is going to separate out the variable cost. So how do we do that? Well, first of all, we want to look for our highest and our lowest points. So if you do so, you're going to see that your lowest point of cost is here for 36,000 with related activity of 18,000 units. So that's our low. Our high is going to be here at 74,500 cost related to 40,000 units. So under the high-low method, those are the only two that we're going to look at. We can ignore essentially all these other data points for high-low, okay? So our focus is finding this variable cost per unit. So how do we do that? Well, we just take the difference, okay? So 74,500 of cost minus 36,000 gives us 38,500. So basically what we're saying is between these two levels of activity, the variable portion of cost is 38,500. Okay, because this is like our highest point and our lowest point. Do the same thing for the activity. So 40,000 minus 18,000 means that we have 22,000 units that are driving that variable cost. So how do I calculate my variable cost per unit? Well, I just take my 38,500 divided by 22,000 units, and that gives me $1.75 per unit. So I'm going to use that as I am working through, I call it a proof, okay? But really what we're trying to do is start with the low and the high points. We should come to the same conclusion for fixed cost now that we know our variable cost per unit, okay? So if I look at this data, I never grab any of the other numbers. I have to use the highest and the lowest points, okay? So total units on the low side is 18,000, and I know that my total cost was 36,000, okay? Now, if that's the case, my total cost is going to equal my variable cost plus my fixed cost. So if I take my 18,000 units times $1.75, what I'm saying about this information is that my variable costs are 31,500, which if this is true, total cost, Y equals MX plus B. B is our fixed cost. So 36,000 minus 31,500 means our fixed costs have to be 4,500. Now, since I use this as the model, okay, my Y equals MX plus B is Y equals some units times $1.75 plus 4,500 of fixed cost. That's my equation that I'm working with. So I know my fixed cost has to be 4,500. I also know that at its highest point, my units were 40,000. My total cost was 74,500. Now at this point, I know my variable cost has to be my total cost minus my fixed cost, or 70,000. But let's proof that out. Is that right? Well, let's take my 40,000 units times the $1.75, and that gives me 70,000 of variable cost. So once I know the model, now I can move in and I can actually do a forecast, okay? So I've got two numbers here. I've got my boss coming and saying, hey, what if we estimate 31,000 units? What are my total costs going to be that are mixed, okay? What's the portion that's variable? What's the portion that's fixed, okay? What's going to vary as my activity changes versus what's going to stay a fixed cost? So a couple of things. I'm trying to find what is my Y, right? But my Y equals my MX plus my B. I know what my B is in both of these cases, okay? 4,500 based off of my model. I know that both of these have to be taken times $1.75. Why? Because that's my X factor in my equation, okay? So I'm going to take 31,000 units, in this case, times $1.75, and that is going to give me 54,250. And then in this estimate, I'm going to take 60,000 times $1.75, and that's going to give me 105,000 of fixed cost. I'm sorry, a variable cost. Okay. So again, here's my variable cost. Here's my fixed cost. I'm going to add those together. Now I can forecast or make an estimate about what my total cost should be. So at 31,000 units of activity, my total costs are estimated to be 58,750, and at 60,000, 109,500. So two benefits of the model. The last thing I want to encourage you to look at is, if I'm turning this into my boss, what's something that I should take into consideration? 31,000 compared to this range. So remember my range, highest to lowest. Low was 18,000 to high of 40,000. Okay, those are the points that I've already operated at. Okay, so this model is really based on these numbers. So 31,000 falls in between there, we're good. But this 60,000, really what we're saying is, well, that's outside of the relevant range. So one of our key assumptions for cost, volume, profit is that we're operating within a relevant range when we're considering mixed cost. So we might just put on the caveat for our boss that, you know, this could be the potential estimate, but that assumes that our fixed costs don't change and that everything operates the way it has historically. So with that, I'm going to go ahead and stop the video. Make sure you feel comfortable with the high-low method. And with our next video, we're going to review the regression and see how it compares to this analysis of high-low when we're looking at mixed cost. And then we're going to move on to finishing up CBP.